Today we are going to learn about mastering Python logging for production environments. We will dive into setting up an effective logging system in Python, tailored for production use, covering everything from configuration to integration with third-party services.
Welcome to our session on mastering Python logging for production environments. In this video, we'll explore the essential aspects of implementing a robust logging system using Python's powerful logging module. Logging is crucial for monitoring and debugging applications in real-world scenarios. Unlike print statements, which are often used during development, logging provides a more structured and professional way to capture important events and errors within your applications. We'll cover various topics, including configuring log levels, managing log files, integrating with third-party services, and ensuring the security and privacy of your logs. Let's dive in and see how you can leverage Python logging to enhance your production applications.
The Python logging module is a versatile and flexible system that allows you to configure and control the logging of messages from various parts of an application. At the heart of this system are loggers, handlers, and formatters. Loggers are the entry point of the logging system. They capture the log messages. Handlers send these log messages to their final destination, which could be a file, the console, or a network destination. Formatters define the layout of the log messages. Understanding these components is crucial for setting up a logging system that is both effective and efficient. A logger can have multiple handlers, allowing you to send log messages to different outputs simultaneously. Log levels, such as debug, info, warning, error, and critical, enable you to control which messages are logged and which are ignored. This flexibility is what makes Python's logging module so powerful and adaptable to various environments. Log levels are an essential part of the logging process, allowing you to categorize the severity of log messages. In a production environment, it's vital to set appropriate log levels to avoid cluttering your logs with unnecessary information while still capturing critical events. During development, you might use debug or info levels to capture detailed information about program execution. However, in production, you typically want to focus on warning, error, and critical levels to capture only significant events. This distinction helps in maintaining readability and managing log size efficiently. Python's logging module allows you to configure these levels globally or for individual loggers, providing the flexibility to adjust them as needed. You can even change log levels dynamically at runtime, which can be particularly useful for troubleshooting issues without restarting your application.
As your application runs over time, log files can grow significantly, consuming disk space and making it challenging to manage logs efficiently. Log rotation is a strategy to address this issue. Python's logging module provides handlers like RotatingFileHandler and timed RotatingFileHandler to manage log file sizes effectively. RotatingFileHandler allows you to specify a maximum file size, max bytes, and a backup count, which determines how many backup files to keep. When the log file reaches the specified size, it's rolled over, with the oldest logs being deleted to make room for new ones. Alternatively, timed RotatingFileHandler rotates logs based on time intervals, such as hourly or daily. This approach ensures that your logging system remains manageable and does not consume excessive disk space, while also ensuring that critical logs are not lost and can be archived for future analysis.
In production environments, integrating logging with third-party services can significantly enhance your ability to monitor and analyze logs. Services like Loggly, Splunk, and others provide centralized log management, making it easier to aggregate, search, and visualize logs from multiple sources. Python's syslog handler allows you to send log messages to a syslog server, which can then forward them to these services. This integration enables advanced features such as real-time monitoring, alerting, and the ability to set up dashboards for visual analysis. By leveraging third-party services, you can gain insights into application performance, detect anomalies, and respond to issues more effectively. This centralized approach not only simplifies log management but also enhances the overall reliability and scalability of your logging system. Exception handling is a critical aspect of any robust logging system. When an error occurs, it's essential to capture detailed information about the exception to aid in troubleshooting and debugging. Python's logging module provides the logging.exception method, which is specifically designed for this purpose. It logs a message with level error on the root logger, and also includes the stack trace, providing valuable context about where the error occurred and the sequence of function calls that led to it. By consistently logging exceptions, you can improve the visibility of errors in your application, making it easier to identify and resolve issues. Detailed logs allow developers to understand the root cause of problems more quickly, reducing downtime and improving the overall reliability of your application.
Clear and well-structured log messages are vital for effective log analysis. In production environments, logs are often consumed by automated systems and analyzed by humans, making clarity crucial. Structured logging involves adding metadata to log messages, such as timestamps, log levels, and contextual information like user IDs or transaction IDs. This additional information makes log messages more informative and easier to parse. Consistency in log message formats is also important, as it facilitates automated log parsing and analysis. By adopting a structured logging approach, you can enhance the readability of your logs and improve the efficiency of log analysis, enabling faster identification of issues and trends within your application.
In production environments, security and privacy of log data are paramount. Logs can contain sensitive information, making them a potential target for unauthorized access. It's crucial to avoid logging sensitive data such as passwords, personal identification numbers, or any other confidential information. Implementing encryption for log files adds an extra layer of security, ensuring that even if log files are accessed, the data remains protected. Role-based access control can also be implemented to restrict access to logs, allowing only authorized personnel to view or manage them. Additionally, compliance with data protection regulations, such as GDPR or HIPAA, is essential when handling logs that contain personal data. By prioritizing log security and privacy, you can protect your application and its users from potential data breaches and ensure compliance with legal requirements.
Maintaining useful and efficient logs requires adopting best practices that ensure logs remain relevant and actionable. Regular log reviews help identify patterns and potential issues before they escalate. Automating log analysis with tools that can parse and visualize log data provides real-time insights and reduces manual effort. Setting up alerts for critical issues, such as application errors or security breaches, allows for rapid response and mitigation. Archiving old logs ensures that historical data is preserved for future analysis, while keeping active logs manageable. Continuous improvement of logging practices involves regularly evaluating and updating your logging strategy to align with evolving application needs and industry standards. By adhering to these best practices, you can maximize the value of your logs and enhance the overall effectiveness of your logging system.
As we conclude, let's recap the essential concepts of mastering Python logging for production environments. We've explored the importance of logging in monitoring and debugging, and the benefits of implementing a robust logging system. From understanding the Python logging module to configuring log levels, managing log file sizes, and integrating with third-party services, we've covered a comprehensive range of topics. Effective logging is crucial for maintaining application reliability and performance in real-world scenarios. We encourage you to implement the skills learned in this session and continue exploring further resources to deepen your understanding. Thank you for joining us, and we wish you success in mastering Python logging for your production environments.